Question 1 says, refer to the following function, x cubed minus 4x squared plus 7. The equation of the tangent line at x equals 2. So in order to make the equation for a line, we're going to use y minus y1 is equal to m times x minus x1. So what we need to do is to identify an x1, a y1, and then m being the slope of that tangent line. So the x1 is going to be 2, and the y1 is the value when you put 2 in for x. So we have 2 cubed is 8 minus 16, which would be negative 8, plus 1, which would be 7. I'm sorry, plus 7, so it would be negative 1. Another way to do this is I have the formula here, and I can just say calculate g of 2. Okay, and we get negative 1 as we expected. So that means that, again, the x1 has a value of 2, the y1 has a value of negative 1, and the slope is the value of the tangent at x equals 2. And hopefully you know by now that that comes from taking the derivative and then putting 2 in there. So if I compute the derivative, I'm just going to use a simple chain rule. And you can see that that's going to be 3x squared minus 8x. And then I want to figure the value of this when x is equal to 2. So I want g prime of 2. Notice that this notation looks real familiar. So now we know that the slope when x is 2 is negative 4. So now I want to put all of that into our original equation, and we get y minus negative 1 is equal to m, which is negative 4 times x minus 2. And let's see, so when we're going to add negative 1 to both sides, and we're going to get y is equal to negative 4x, let me see, plus 8 plus negative 1, or y is equal to negative 4x plus 7. And that answer is B. So the two math ideas are the use of derivatives to find the slope of the tangent line at x equals 2, and then to use a linear approximation to estimate function values near the known value. So now we have this function y equals negative 4x plus 7. That is the line tangent to the function at x equals 2. So if I want to estimate f of 2.1, I'm going to simply type in here, I'm going to plot a new function, negative 4x plus 7, which is a line, obviously going down there. And then I want to put 2.1, sorry, into that. So I'm going to do h of 2.1, and you get negative 1.4. So that's the answer for that one. Now, just as an aside, I'm going to show you what exactly this function looks like, just so that we can really get a sense of the ideas here. So I'm going to move these out of the way. All right, and what we want to do is graph the original function. So if I plot the function, I already have the function, right? I just want to plot this function. Notice when x is 2, here's your this is the function, and here is the equation of the tangent, and that is the tangent line. So when x is 2, you get it looks like it's right about here, and there's the tangent line. So g of 2 is negative 1, and the slope of the tangent line again is negative 4, and so there you go. And now if we look at 2.1, which is just a little bit over, you can see that it's an excellent approximation because it lies on the tangent line and also on the function, or at least very close to it.